we want to find area enclosed by this lemniscate whose equation is r square equal to 4 cos 2 theta. Now the left hand side of this equation is always non-negative because it's r square. So if we want to draw a graph of this function, we must choose those theta in the domain for which cos 2 theta is always non-negative, so that this equation is valid. So how do we find theta such that cos 2 theta is always non-negative? So let's observe that cos theta completes one cycle in the domain when theta varies from 0 to 2 pi. But cos 2 theta, it completes two cycles in the same domain from 0 to 2 pi. Cos theta is positive in the first and fourth quadrant. In case of cos 2 theta, theta's multiple is 2. So in order to find values of theta for which cos theta is going to be positive, what we do is we divide each quadrant in two equal parts because multiple of theta was 2. So we divide each quadrant in two equal parts and that will give us 8 quadrants. So we take these 4 quadrants and divide each one of them in two equal parts by this ray, where along this ray theta is equal to pi by 4. Along this one theta is 3 pi by 4, 5 pi by 4, 7 pi by 4, right? So we actually label all these rays. This one is 0 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4. After that, we label each one of these regions, or you can call them quadrants, 1, 2, 3, 4, 1, 2, 3, 4. Why do we do that? Because cos theta completes one cycle in these 4 quadrants, 1, 2, 3, 4, and it's positive in first and fourth quadrant, right? Now cos 2 theta is going to take exactly same values in these quadrants, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's one way to find out values of theta for which cos 2 theta is going to be non-negative. So now we know that cos of 2 theta will be positive in 1, 4, 1, 4. So this is where the graph of the given function is going to lie. Now we know the domain of this graph. So let's check if this graph is symmetrical or not. If we change r to negative r in the equation of this graph, what happens? The equation doesn't change because we have r square. So what does that mean? That means the graph is symmetrical about origin, which means the graph is same in the first quadrant and third quadrant. So the graph here will look like graph here, and the graph in second quadrant is same as the graph in fourth quadrant. Okay, now we change theta to negative theta. So this is the equation. We change theta to negative theta. What happens? R square is equal to 4 cos minus 2 theta, which is same as 4 cos 2 theta because cos is an even function. So changing theta to minus theta is not going to change the cos function. So the graph is unchanged if we change theta to minus theta, and that shows that graph of this function is same above and below axis. So we make the graph only in the first quadrant and copy and paste it in the about x and y axis. Why is that? Because the graph here looks like the graph here. The graph in this area looks like the graph in this area, and now we know the graph here looks exactly like it's a reflection of the graph here. So what does that tell us? That the graph in all these 4 areas is exactly the same. So if we want to find area covered by this lemniscate, we draw the graph in this quadrant and find the area enclosed by this graph and multiply that area by 4. Okay, so now in first quadrant we draw the graph for theta equal to 0 to pi by 4 because that was the region where cos 2 theta is going to be positive, and that's the domain. Alright, so how do we do that? r square is equal to 4 cos 2 theta. So what happens when we substitute theta equal to 0? R square is equal to 4 cos 0 and cos of 0 is 1. So this is equal to 4 and then r becomes equal to 2. When theta is pi by 4, r square is 4 cos pi by 2, which is equal to 0 because cos of 90 degrees is 0. So in a way, r is maximum when theta equal to 0 and the maximum value is 2, and r is minimum when theta is equal to pi by 4. So let's look at values of cos theta in the interval 0 to 2 pi. So when theta changes from 0 to pi by 4, the cos values are changing from 1, cos theta values are changing from decreasing from 1 to here, right? So the cos theta value is decreasing, so cos 2 theta is also decreasing. So that means r square is 4 into a decreasing function. So r value is also going to decrease. So as we can see from the graph looks like this petal here, and we draw exactly, we take its reflection across x-axis, and this same figure here and in second quadrant. So what happens is when theta is equal to 0, then r is maximum equal to 2. And as theta changes, we move in this direction, r value decreases. As you can see, we draw these rays and we see the r value is decreasing. And r lies, what's the maximum value of r? Here. For given value of theta, what is r? This distance. So the r value is decreasing as we move from 0, theta equal to 0 along x-axis to theta equal to pi by 4, and when theta is pi by 4, r value is just 0. Okay, so this gives us the one of the 4 petals, and we need to calculate area enclosed by this petal and then multiply it by 4 to find the total area enclosed by the lemniscate. So this is the formula for the area: 4 times double integral of r dr d theta, where r, what is r? R is the Jacobian with respect to the polar coordinates. So now we want to find limits of r. So when we draw a ray starting from origin across this region, it will enter the region when r equal to 0. So the lower limit will be 0, and it will exit the region through this point which lies on the curve. What is this curve? This is the given curve, and what's the value of r on this curve? R equal to 2 square root of cos 2 theta. So the upper limit is going to be 2 square root of cos 2 theta. Now what about limits of theta? Theta is going to change from 0 along this x-axis to pi by 4 along this ray. So the limits of theta are 0 to pi by 4. And then we multiply this area by 4 to find the